We now turn our attention to Supplement 7, Capacity Planning. In order to plan for or manage capacity, we need a working definition of capacity. So here it is. Capacity is the throughput, or the number of units a facility can hold, receive, store, or produce in a period of time. In other words, it is a rate of units per time. Capacity also has a very high influence on our fixed costs and whether or not demand will be satisfied. You can think of this as how large a warehouse you built to hold finished goods. The fixed costs associated with a larger warehouse are generally higher. Also, if you have a larger warehouse to hold finished goods, it's more likely that you will have enough of the product to satisfy customer demand. When planning for capacity, 3 time horizons are often considered. There is the long range, intermediate range, and short range planning. For each time horizon, we need to consider both options of modifying capacity and using the current capacity. For long range planning, we have numerous options to modify capacity, especially in terms of building additional capacity. On the other hand, there are very limited options or decisions we can make that directly influence our immediate use of current capacity when planning for the long range. At the intermediate range, we have options for both modification and using capacity. You see a few examples of both here. In short-range planning, we primarily have options related to using our current capacity. Much of this is scheduling related, and we will revisit this topic later in the course. We can further distinguish between design capacity and effective capacity. The theoretical maximum capacity is called the design capacity. In essence, it is what the system was technologically designed to be able to do. Effective capacity, however, is the capacity the organization expects to achieve given current operating constraints. These constraints might be something like downtime of a machine for scheduled preventive maintenance. Because there are constraints in place, the effective capacity is almost always lower than the design capacity. Using the concepts of design and effective capacity, we can compute 2 other important metrics, utilization and efficiency. Utilization is simply the amount of actual output achieved divided by the design capacity, while efficiency is the actual output achieved divided by the effective capacity. Take a few seconds and tell yourself which one of these should be larger than the other. Did you figure it out? Let's look at an example to see if you were right. In this example, we are making delicious cinnamon rolls. We have some data that is relevant. We have the design capacity given to us in 1,200 rolls per hour, the operating hours of the line, the effective capacity, and finally, the actual number of rolls produced by the line last week. We should convert the design capacity into the same units, rolls per week. To do so, we simply multiply the design capacity in rolls per hour by the number of hours in the week. 7 days per week, 3 8-hour shifts, 24-hour days, right, times 1,200. The result is a design capacity of 1,600 rolls per week. Based on our previous discussion, it should not surprise you that the design capacity is larger than the effective capacity. With the design capacity converted, we can now calculate the utilization of the line. In this case, it is approximately 73.4%. We can also calculate the efficiency of the line as approximately 84.6%. It should come as no surprise. It should not surprise you that the efficiency is higher than the utilization. If it does surprise you, you should revisit the formulas and convince yourself otherwise. The metrics we've calculated are important, but often we may want to know the expected output of a process. To find the expected output of a process, we take the effective capacity and multiply it by the efficiency. To extend our bakery example, the bakery now wants to expand capacity by adding a second production line for our delicious cinnamon rolls. The second line is a duplicate in machinery, setup, etc. So, what is the expected output of the new line? Because this is a new line, management has decided to estimate the efficiency of it lower than the current line that is stable. The original is 84.6%. Reasons may include the fact that we would probably hire new employees to work on this line. The line might have, quote, kinks to work out, end quote, etc. Here, they estimate the efficiency of the new line to be at 75%. With this number, we can calculate the expected output of the new line at 131,250 rolls per week.